Hello, Catherine. We hope you are doing well. The Data Wranglers team, which includes Gabe, Molly, Lauren, Cameron, and Eden, have completed our analysis on Chocolate Hawkeye. Taking into consideration your objectives of lowering costs and reducing emissions, we have made a recommendation for each of your products, which you will see at the end of this video. The following report contains all the steps we took to analyze Chocolate Hawkeye and what led to our eventual recommendations. For the first step, we found the total demand in units by creating a pivot table and found the sum of demands in units for each product. This was done by putting the product into the rows field of the pivot table and the sum of demand in the values field. We then took the average weekly demand by taking the average of each week's demand for all four products. Additionally, we found the standard deviation of each product using the stdev.s function for each product. For the next step, we wanted to find the average weekly demand weight. This was found by taking the average weekly demand in units, which we found in step 1, and multiplying it by the product weight. We also found the standard deviation by multiplying the standard deviation of weekly demand by product weight.
Two key costs that were important that we calculated were the transportation cost and the emission cost. So at the top you can see the given assumptions. And in order to find the weekly transportation costs, we took the transportation cost per pound and the average weekly demand in pounds, and we multiplied those together. And this helped us get to the transportation cost per unit because we took the weekly transportation costs and divided it by the average weekly demand in units. Then, in order to find the weekly emissions in kilograms, the distance from the plant to DC in miles, emissions in grams per pound mile, and average weekly demand in pounds were all multiplied together, and then we had to divide them by 1,000 in order to convert from grams to kilograms. And to find the emissions per unit in kilograms, the emissions were divided by the average weekly demand in units. And so that is how we found the transportation and the emission costs, which were both very important costs.
The next cost that needed to be found was the inventory holding cost per unit. This was calculated by finding the holding cost per week, which was found by taking the annual holding rate, dividing it by 52 due to 52 weeks in a year, and then multiplying it by the unit cost. Next, we found on-order inventory using the formula of mean of the demand times lead time. Then we found on-order inventory from the formula the square root of lead time plus 1 times the demand standard deviation of demand times the safety factor, which was assumed to be 2.33. Then we added on-hand and on-order inventory together and multiplied this by the holding cost per week to find the weekly inventory holding cost. Lastly, we divided the weekly inventory holding cost by average weekly demand in units to find the inventory holding cost per unit.
Another important calculation that had to be found involved finding the labor cost per unit. This is important because it gives insight into how much a business is paying workers to produce each unit. To find the labor cost per unit, we took the given labor rate and labor hours per unit and multiplied them together. Finding the labor cost per unit played a factor in our recommendation because we are trying to find a way to maximize profits, which is easier if the labor cost per unit is lower. The calculation of the labor cost per unit led us to finding the total cost per unit by adding transportation cost, inventory holding cost, and labor cost together. And then we took the revenue per unit and subtracted it by total cost per unit to get the profit per unit. Then we took the average weekly demand multiplied by 52 and by the profit per unit in order to find the annual profits. Finally, to find the annual emissions, we took the weekly emissions, which we found in step 3, and then we multiplied that by 52 in order to find our annual emissions.
Based on our data analysis, we bring forth recommendations for which plant and transportation method to utilize for each product. We chose the following methods in order to maximize profits while also being eco-conscious and lowering emissions. For product number 1, we recommend Plant 1 utilizing the truckload. Truckload is a much less costly method in comparison to the heavy air cargo alternative. The truckload also has much fewer emissions. The annual profit will be $3,251,119 and the annual emissions will be 30,257.5 kilograms. For product number 2, we recommend Plant 2 using the ocean container. This option has a slightly higher emissions than that of the truckload, but also comes with higher profits. The annual profits will be $4,631,000 $541 with annual emissions of 53,130.17 kilograms. For product 3, we suggest Chocolate Hawkeye utilize plant 2 and the ocean container. Your company will make a profit of $942,753 and emissions of 63,672.34 kilograms. This option has substantially higher profits and much lower emissions. Finally, for product number 4, your company should utilize plant 2 with the ocean container. Much like product 2, we chose a method that has slightly higher amount of emissions, but this also comes with higher profits. With these options, product 4 will make $1,735,574 in annual profits and produce 7,445.77 kilograms of emissions annually. We hope Chocolate Hawkeye finds these suggestions useful in creating an optimal supply strategy. Thank you.